Hello, students, YouTube learners. This is Dr. Satish Singhal, PhD, Professor of Computer Science at Camino College, Torrance, California. This video is on looping control structure, video 1. Sorry, I don't have any idea how many I'll be doing in this. So, excuse me. So, I don't know whether last video will be 5, 6, what. So we're just gonna go with numbers 1, 2, 3, etc. So let's start. Computers shine when they execute a bug-free algorithm repeatedly, as due to their vast speeds, computers can do repetitive tasks accurately, speedily, and efficiently compared to humans. And control structures where a computer executes the same algorithm repeatedly is called looping. Alternate names for looping are repetition and iteration. So sometimes looping structure can also be called repetition control structure or a iteration control structure. Okay. One example is count control loops. And we'll take a general life example because looping in real life is more common than realized. Here are some examples of looping in real life. Suppose you got an assignment to read a book in a class and to do a book report on it. Then book reading algorithm using looping control structure would be something like this. N is the number of pages to read. So while n is not equal to 0, read another page. When you read another page, your n changes to n minus 1. So notice that this n will be, with each loop cycle, will be brought closer to 0, and when it becomes exactly 0, 0 not equal to 0 is false, and loop will exit. A couple of things I want to point out. Loop enters and executes the loop body statement, which are these two, as long as loop condition n not equal to 0 is true. When n not equal to 0 becomes false, and that would be when n is actually becoming 0, 0 not equal to 0 is false, then whatever the statements are here, they would be executed. So loop exits when loop condition n not equal to 0 evaluates to false, and statements after the loop body, if there are any, may execute. I also want to point out the pseudocode, because you will be doing that in your IOA. Notice how we do that. We have the word while, and in parentheses we have the loop condition. That's actually similar to if. You have if or else if and a condition. Notice there's no word then. We are not allowing word then in case of loop, because there's no alternate task. Okay? Either you do this task or no, do nothing. So sometimes students get confused because they think that a condition is being tested, then it is similar to if and else somehow. It's absolutely not. The condition is only being tested to make sure that if this condition is true, then loop body executes. Otherwise, if this is false, then loop body is not executed, and there are statements, whatever happens to that after that. And the loop ends with the word and while. Okay, there are other loops like for, do while. There will be equivalent ending statements for those. But right now in this chapter we're going to concentrate on while loop. So that's the pseudocode or algorithm writing style for the while loop. Okay. Okay, so loop such as this one is called a count control loop because in such loops, computer knows in advance as to how many times the algorithm inside the loop will execute. So obviously when you start to read a book, you know in advance how many pages there are in the book. Okay, teacher cannot give you a book to read where he says, okay, I don't know how many pages there are. You keep reading and we may increase pages or we may decrease the pages later on. No, no such thing. The book has fixed number of pages. You're reading it. Reading algorithm reads one page at a time. So book reading loop will execute fixed number of times and it is known in advance how many times it will execute. Okay. So in this case, this book reading algorithm executes n times, which is equal to number of pages in the book. So that's the characteristic of count control loops. We know in advance how many times it will execute. There are other examples of that in real life. Let's say a company has 200 employees and they want to print paycheck for everyone. Then paycheck printing machine knows in advance that it has to print 200 paychecks. When you want to print address labels and that every sheet has fixed number of labels, then your printer knows in advance how many times it is going to print the address, because it knows from the model number of the sheet as to how many labels are on that sheet. Okay. If you are going to produce cars in a factory, you know in advance how many cars you're going to be producing in one day. So car producing loop will run that many times. And there are lots of other examples, similar way. So count control loop is one of the loops that is very common in computer science. The other thing we want to talk about, this loop we just looked at, it's also called a pretest loop. And that's because you are making a decision about testing the loop condition at the entry point of the loop. Okay, this is the entry point of the loop, this is the exit point. So right before you enter the loop, you're making a decision about truthy or falsy value of the loop condition at the entry point. So another name given, because testing is done at the entry point, the name pretest loop is given to such names. Now pretest loops have an interesting property that depending upon the value of loop variable, which is in this case of n, the loop condition may evaluate to false and loop may not run even once. Okay, loop is never entered even once. That's an amazing property pretest loops have. There's another test loop called do while, which is called a post test loop, and that has to run at least once. But pretest loops do not have to run even once, depending upon that very first time whether this condition evaluates to true or false. Now, for example, though it may sound very strange, that if you were told not to read a book, then in this case n will be 0. 0 not equal to 0 is false, and this book reading loop will never even enter. Okay, so that's the characteristic of pretest loops. So just remember that, because one classification criteria of the loops is all loops fall into one or the other category. They're either a pretest loop because testing is done at the entry point, or they're post-test loop because testing of the loop condition done at the exit point. That loop is called do while. We'll work with that pretty much later at some point. Okay. We want to do a schematic representation of while loop. Pretest loops whose signature line uses the reserved word while is also called a while loop. And typical while loop would be similar to this figure. You have signature line where there's word while. Inside the parentheses will be Boolean expression being tested. Okay. Left curly brace, right curly brace. And inside the loop body, you could have one statement, two, or if you don't want to execute anything, you don't have to, but then it will become infinite loop. So a null statement is not a good idea. I have it here, but it shouldn't be null, because at least this loop condition has to be updated. Okay, so strike this out. No null statement. It has to be at least have one statement that'll affect this loop expression. So that's the syntax: while, expression, left parenthesis, right parenthesis. In between these two are the loop statements. Okay, loop, that's called the loop body, by the way. So the way also we talk about loops is that this is the signature line of the loop, which includes the word while and the Boolean expression that's being tested. And that's the loop body, where first statements start after the curly brace, last statement is before the curly brace, and this part is called loop body. And that's the rule all through. Any variable declared inside the body will not be visible outside the body. So just don't forget that part. That was true even in if and else, that if you have if some expression, curly braces, curly brace, and if any variable is declared here, that's not going to be visible here or anywhere else. Flow chart of the while loop is like this, that diamond means expression is being tested. If expression is true, we'll execute the loop body statements, and we'll, after executing the last statement, we'll go back and test the expression again. If that's still true, we'll go back here. So we'll stay in this loop, so to speak, as long as this expression keeps evaluating to true. Once it evaluates to false, we get out and start to execute other statements after that. Okay, so loops do not have alternate tasks like if and else does. It just has a task which is done if expression evaluates to true. If expression does not evaluate to true even the first time, then loop is not entered even once. That's called a pretest loop. Otherwise, loop body at some point will change this expression, and at some point it will become false and we'll exit the loop. If we don't exit the loop, we'll just stay in this loop in this manner in which I'm rotating my mouse. Okay? All right. The second type of loop are called, we said first type of loop was count control, where computer knows in advance how many times loop will be executed. But there are situations where computer doesn't know that. Those situations where computer doesn't know in advance how many times the loop will be executed, those are called event control loop. Okay? So summarizing, all loop designs are not such that computer could know in advance as to how many times a looping algorithm will execute. In such cases, an event inside the loop body must take place that will render the loop condition to be false, okay, causing the loop to exit. Such loops are called event control loops, and we have next slide that gives a schematic example of event control loops. One example. Okay, suppose an athlete is doing push-ups. Then he will be in a push-up loop until he gets tired. Pseudocode for such a loop can be given as follows. E is the total energy to do push-ups. Total means if athlete can do 100 push-ups, then E is the stored energy for that many push-ups. So our loop is while E is greater than 0, then do one push-up, and obviously you're hoping that there will be some reduction in E. But sometimes it doesn't happen that way all the time. Sometimes it might increase. but at least at some point you will start to see some reduction in E. And this push-up loop will keep going until E has become 0. 0 greater than 0 will be false, and that's when you exit the push-up loops. At some point, athlete has to get so tired that he or she does not have even energy to do one push-up. At that time, their energy is E is 0, and then E greater than 0, 0 greater than 0 is false, and they will exit the loop. In this example, it's a physical process. We cannot make an assumption that reduction in E is a linear function of number of push-ups done. I already said that sometime after doing one push-up, energy may actually go up. At some point it has to start coming down. But we cannot make any assumption the reduction in E is a linear function of number of push-ups done. Thus, no prediction can be made about how many times a loop may run. Computer would just need to watch out for the event when E equals 0 is true. Computer just has to watch out when athlete has run out of energy. At that time, loop condition E greater than 0 will become false and loop will exit. Actually, this condition E equals 0, when it becomes true, is called a termination condition. So, what is the event happening in the loop? Simple. Termination condition has arrived. In this case, termination condition was E equals 0. It might be different for some other cases. Okay? Loops like that, where an event happened, in case of athlete getting so tired that cannot do another push-up, is the event, energy 0, which we cannot predict in advance most of the time. Okay? Such loops are called event control loops. We will give more example of event control loops as we proceed through. Next thing we want to talk about various parts of a loop. Design of loop is not possible without understanding what are the various parts of a loop. So we label different parts of a loop by revisiting the two loops we have discussed so far. First, we'll just name them. I think I'll revisit in this video just one. But all loops have 4 parts. Here I'm just doing a laundry list. Next slide I'll show you what they are. Initialization of loop Boolean condition. Testing of loop Boolean condition. This is done at the entry point for the pretest loop and at exit point for the post-test loop. Third part is loop task, could be one or more. And then it's very important that update of loop condition is done. Now, this doesn't mean it has to be done after the loop task. It can be, that depends on the loop design. It could be done, like 4 can be done before 3 or 3 can be done before 4. That's not fixed. But what is the update of loop condition? This one is most important, because if update is not done, the loop condition will always maintain the entry point condition. And you remember the entry point condition was that condition is true. So if condition remains true always at the entry point, that means you can keep entering loop infinitely. That becomes infinite loop. Okay? Update is the most important, and that's most often forgotten. Okay, one more time we want to show 4 parts of the loop in this form, in this kind of flowchart form. Initialization is the first. Loop condition or variable is initialized. Testing of the loop condition is number 2, pretest. Condition is tested whether it's true or false. Loop task, If loop condition test is true, then I'll enter the loop and loop task. Here we are showing one box, but it could be more than one. And then loop condition is updated. Update may keep loop condition as true or may render it false. If it renders false, then we exit the loop. If it keeps it true, we continue the loop. Now I did say I'm gonna point out these four for the loops we did, but looks like I didn't do that in this one, but that's pretty easy. We'll just go back to the previous two loops we showed you, count control and and the event control. So here are the four parts. N equal to number of pages to read. That's the initialization of this variable n, which will be used in the loop condition. Number one. N not equal to 0, being tested, this will result in a boolean true or false. That's the part number 2, which is the test or pre-test of a loop condition. Loop task is read another page, that's number 3. And fourth part of the loop, n equal to m minus 1, reduction in number of pages to read by 1. That's the loop update, okay? And same way, let's go to the other loop here, event control. E equal to energy to do push-ups. So E will get set to some value. That's the initialization of the loop variable or loop condition. Testing that E is greater than 0. That's the second part of a loop. Do one push-up. That's the loop task. Reduction in energy E. That's the number 4 update of the loop condition. Okay. So those are the four part of the loop. Here I've shown them kind of using my mouse. In future, when I do more code, I'll show you that by putting numbers 1, 2, 3, 4. Okay. All right. We've already gone through this. Okay. Let's just consolidate this. We'll keep pointing to various parts of a loop as we do more loop pseudocodes and source codes. For now, let us proceed with the classification of event control loops. Yeah, so count control loop is just by itself, just one class where computer knows in advance how many times the loop task will be done, okay? But event control could be many different types of event could take place inside the loop. So they have sub-classification. Event control loops have sub-classifications. And that's what we're going to show you now. So just try to understand, have a macroscopic picture. All loops could fall either pretest loop if loop condition is tested at the entry point, or if loop conditions is being tested at the exit point. Those are called post-test loop. That's one classification. Other will be that when computer knows in advance how many times loop is going to execute, that's called count control. When it doesn't know and it depends on an event taking place inside the loop to exit, like an athlete running out of energy to do even one more push-up, that kind of event, those are called event control loop. But event control loop themselves are classifiable in 3 different types of loops. And we'll spend a lot of time in first of 2 of those 3. And those are event control loop, could be sentinel control loop, end of file control loop, or flag control loop. So in next video, let's do it this way. Next video I'll only do a sentinel control loop because I think I have a video on that already. Then video after that I'll do end of file control loop and flag control loop. This one is the smallest one. And after that I believe I'll do nested loops and design example 5. So let me say goodbye to you from video number 1 with classification of event control loop. In next video we'll begin from this classification and we'll discuss just the sentinel control loop. Okay? Goodbye from video 1.